students, welcome to Chemistry Champs. In this video we will learn about VSEPR theory. So what is VSEPR theory? It is a valence shell electron pair repulsion theory. In this basically we are studying about repulsion between electron pair present in valence shell. In 1940, Sidgwick and Pohle give some simple rule relating to the structure of molecule. And in 1957, Gillespie and Nyholm suggest some addition to these rules. So, the arrangement of bonds around the central atom are depend upon the following factor. First is the number of valence shell electron pair, and second is the arrangement of valence shell electron pair as they are present as a lone pair or as a bond pair, and third is size and shape of these orbitals. Now we study some basics to VSEPR theory. So, using the VSEPR theory, we find the spatial arrangement of molecules having coordination and covalent bond. The electron pair are present in two types. First is bond pair and second is lone pair. And there are three types of repulsion present. First is bond pair, second is bond pair, lone pair, and third is lone pair repulsion. And the lone pair are not considered in the shape of molecules. And in order to represent the shape of molecules, at least 3 atoms and 2 bonded pair are required. Now we move on to the postulates of VSEPR. So, postulate first is the lone pair of electrons repel the adjacent bond pair more strongly than the bond pair repel the same electron pair. So, the repulsion factor in decreasing order as lone pair repulsion, lone pair bond pair repulsion, and bond pair repulsion. For example, in this H2O, there are 2 lone pair are present. First is this and second is this. So, there is lone pair repulsion. So, the bond angle will be 104.5 degree and repulsion is more. And in NH3, there is 1 lone pair is present and 3 hydrogen atom is present. So, the repulsion between lone pair and bond pair. So, the bond angle is 107 degree. And in this CH4, there are 4 hydrogen atom are attached. So, the bond angle will be 109 degree 28 minutes because in this bond pair is present. And in this direction, bond angle is decreases and repulsion is increases. Second postulate. The repulsion exerted by bond pair of electron decreases as the electronegativity of the bonded atom increases. In this H2O and in this F2O, there is fluorine is most electronegative atom and the repulsion is more and the bond angle is less. And as in same case NH3 and NF3, F is most electronegative, so the bond angle is 102 degree and repulsion is more. Third postulate. The multiple bond do not affect the stereochemistry of a molecule. Rather, the geometry is determined primarily by sigma bond and number of lone pair present. For example, SF4. In this, 1 lone pair is present and they have trigonal bipyramidal geometry. In SOF4, in this, they present a double bond. So, they do not affect the stereochemistry and they also have a trigonal bipyramidal geometry. Postulate number 4. Repulsion between an electron pair is greater in filled shell than in incomplete shell. For example, H2O has a greater repulsion than H2S and H2S has greater repulsion than H2SE and H2SE has a greater repulsion than H2TE. Postulate number 5. When an atom with 1 or more lone pair in his filled valence shell bonded with an atom with an incomplete shell, So there is a tendency for the lone pair to be partially transferred from filled to the unfilled shell. Now we move on to the sixth postulate. So the triple bond cause more repulsion than the double bond, and similarly double bond cause more repulsion than the single bond. Now we move on to the limitation of VSEPR theory. So it does not explain the shape of molecule which have very polar bond, like Li2O and H2O have same formula, but Li2O is linear and H2O is angular. Second, it cannot explain the shape of a molecule or ion which are extensively delocalized pi electron system. Third, it cannot explain the shape of molecule which have inert pair of electron. Now we explain the structure of NH3 on the basis of VSEPR theory. So in NH3, nitrogen is a central atom and its electronic configuration is 2s2 2p3. So in outermost shell there will be 5 electrons are present. In this 3 p orbitals or 3 electrons are bonded with hydrogen atom and the rest of the 2 electrons are called lone pair. So in ground state this will be 2s2 2p3 and in excited state this will be 2s2 2p3 and these 2p orbital are bonded with 3 hydrogen atom and they form sp3 hybridization. So there is a share of 8 electron in outermost shell in which 4 pair of electron give rise to tetrahedral structure, and there is due to presence of this lone pair, distortion is present from 109 degree 28 minute to 107 degree 28 minute. Thank you so much guys for watching this video. Hit the like button, share with your friends and subscribe to my channel. Thank you so much.